Hello, hi guys. Welcome to another video of Chalk Talk in the networking technology. Today we are going to discuss very interesting topic called network addresses. So let's get started. So network addresses, guys, there are two type of network addresses. One is MAC addresses and other one is IP addresses. In IP address, there are two type of IP addresses: IPv4 and IPv6 addresses. Okay, so MAC addresses, let's talk about the MAC addresses. MAC address is generally used in the L2. What is L2 and what is L3? Maybe it will be clear in the upcoming videos. So I'm not going to spend too much time in the L2 and L3, but MAC addresses, there are total 6 octet in the MAC table, and 3 octet for UI and 3 octet for network interface card. But this is maybe not that much important. The important is how and which device use MAC addresses. So MAC address is used by the switch, right? So switch, what is the switch, right? Switch is nothing but a device, a networking device, which do mainly two things. One is learning of the MAC addresses and forwarding. Now in forwarding, it do two things, right? Either it will flood the frame, or it will just forward unicast. So meaning when the host A, let's suppose this is the host A and host B. Now when this frame comes to this switch, right? Switch to either the learning or forwarding. Now learning is like if the switch does not know the A MAC address, switch will learn always, just remember, switch always learn the source MAC address of the frame, right? And forwarding happen based upon the destination MAC address. Now when the A sends a packet, if the destination MAC address has number start from 0 1, remember it is always a multicast. It is always and always a multicast uh, frame. Now if it is FF FF, right, all the 6 octets are FFF, it means it is a broadcast. So this is broadcast and this is multicast. So what the switch will do in case of broadcast, in case of multicast, is like when the multicast comes, right? Multicast switch A packet will go to B, and this only the selective destination or the host multicast receivers. In case of broadcast, it will be flooded to all the ports except the incoming ports. In this incoming port, it will not be flooded. Okay, so this is flood. So remember, flood, there are two type of flood: multicast and broadcast. Now forward is like this switch knows that the B is on this port of the switch, right? So what will happen when the A sends a packet or frame, it will go to the B in a unicast. This is called as the forwarding. Okay, this is called as the forwarding uh, of the frame. Now let's talk about the IP addresses. So this is all about the MAC address, and this learning and forwarding is very important, guys. It will ask in many companies what is the switch behavior, how the switch functions, right? So it's learning and the forwarding. So these are the two functions that the switch always performed. Okay, so let's discuss about IPv4 and IPv6 address. Now IPv4 is like this: 192.168.3.4. So there are total 4 octets. So in MAC address there are 6 octets, and IP there are 4 octets. So you see, dot 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 dot. So there are 4 octets. Now these are represent in the decimal. Decimal numbers are 0 to 9, and MAC addresses are shown in hexadecimal 0 to F. Okay. Now similarly IPv6, these are the IPv6 octet, right? So this IP, this is slash 32 uh, subnet mask could be. So meaning each octet it's of 8 bits. Okay. Now in this case it is 128 bits. Okay, and it also showed in hexadecimal 0 to F. 0 to F. Okay. Now this is IPv6. Now in IPv4, just remember, guys, this is very important, that the next topic that we are going to discuss is IPv4. There are two address. One is public address, one is private address. Now public address are the one which is routable on internet. Let me minimize this. Routable on internet table. Private not routable on internet, and RFC 1918 discuss about this, right? What is RFC? RFC is a request for comment which discuss about this. Okay, now public address is always, if you see this namespace somewhere, okay, this one, this class A 1.0.0 to 126, so these all are public address. In class B 128 to 191, in class C 192 to 223 to 255, these all are public addresses. Okay, now what are private addresses? Private addresses are RFC 1918, as I discussed, and these all are the private addresses. Okay, this one RFC A 255, this one 10 to 10.0.0/8, 172.16.0/12, 190 to 168.0.0/16. These all are RFC 1918. Now, what is this private and what is this public address? This is, very important topic I want to discuss with you, because this is also this is one of the topic which I the understanding I built later part of my career is like, okay, so private address, it means, okay, let me write down this. Private, it means this is private to you. So let's suppose there's the company A who has their own data center. Okay, their data center, so they have a servers here. Okay, let me put this here. So they have some servers here. Now these servers will have a IP address in the range of private 0.0.0/8 or 172.16.0.0/12 or 192.168./24, right? So they have a IP address, let's suppose 10.1.1.1. They have this IP address. Now let's suppose there is a DNS server here in the public cloud. Okay, this is my public cloud. Okay, so this DNS has IP address 1.1. Let's suppose 1.1.1.1 or 8.8.8.8 or 4.2.2.2.2, right? So there are many private public DNS. Now remember, this 10.1.1 cannot ping 1.1.1. Okay, so meaning is let me write down this. Private IP cannot talk to public IP. That's the first point. Okay, now second point is IPv6 cannot ping. Okay, so this private IP cannot talk to the public IP. Meaning, if I want 10.1.1 communicate with 1.1.1, they can't. They cannot ping. Just if you want to test this, how you can do a testing, maybe you have a GNS server or something, just connect to PC like this, okay, in your private lab, and connect with the some cable, maybe right here like this. Assign the private IP and the public IP, and then just try to ping. Okay, even though if you have a routing or anything, they will not be able to ping each other. So how this works is like there will be a one device in between. I guess you have guessed it correctly. The device is net network address translation. So what this device will do, it will convert this private IP into the public IP so that it can talk to the public IP. Now vice versa, meaning this public IP, when the reverse traffic comes, this NAT will convert this public IP into some private IP so that it can talk to the private IP of your organization. So make sure, always do a NATing when you want to do this connectivity. Okay, so this point is very important. Private IP cannot talk to the public IP. You need a netting device. Now, however, okay, so we will discuss this in detail of the IPv6, how it is different in the IPv6. Okay, now let's discuss about the IPv6 and the subnetting of IPv4 quickly. Now subnetting. Okay, so IPv4 subnetting. Now IPv4 subnet mask is like so if you see /24, like this /24, /32, what is the meaning of those? Is like so this 255.25/24 is the subnet masks, right? So meaning, if you see any IP address like this, right, 192.168.1.1/24. Now /24 is this one, 111. Just do the AND operation of these two. Meaning, what is the meaning of? So if I write down 192.168.1.0, right? So what AND will give the output 0 of 0, right? 1, 168, 192. So meaning this is my network portion. This is my network portion, and 0 is my host portion. So maximum how many IP I can have, right? Here, so this is 8 bit, right? It's 2 raised to power 8 minus 2. Why minus 2? One is network bit, other one is broadcast bit. So I have subtracted those two. Now, if you see this IP 192.168.1.10, you know what is this? Till here it is my network ID, and this is my host ID. Dot 10 is my host IP. Now, in case of IPv6, you may be wondering IPv6 subnetting is difficult than IPv4, but it is exactly the same, or even I would say it is even easy, because I have worked on one of the company which is complete IPv6 stack. So one more thing, something called, maybe you have heard of dual stack protocol. Dual stack. So what is that dual stack? Dual stack is a device which works on IPv4 plus IPv6. It's called as a dual stack. Okay, if the device cannot work on IPv4, it is a single stack. If device cannot work on IPv6, it is a single stack. But if the device works on IPv4 and IPv6 both, it is a dual stack. So most of the application, it depends on the application, right? So if you are developing application, make sure the application is dual stack, meaning it supports both IPv4 and IPv6. Now, in terms of private and the public IP, as we discussed in here, right? um, Let me discuss in the case of IPv6. Okay, in case of IPv6, private and public IP is very much same as IPv4. Okay, so in case of IPv6, if you see um, any address starting with 2000, okay, let me write down so that it is clear to you guys. Okay, okay, so if you see any IP address starting from 2000, it is a public IP. Okay, now if you see any IP address start with FC00, it is a private IP. It's as simple as that. Okay, now you have seen another IP address which is that's the beauty of IPv6 is a link local address FE80. So what happened, whenever you boots up any device in the IPv6, okay, it assign automatically one IP address on its own. Unlike IPv4 has a APIPA address, right? 168 range. Similar like this FE80 is the link local address which is assigned by the any interface on its own, right? But remember, this any IP address which start with the IPv6 address start with FC00 is the private IP, and any IP address start with 2000:3 is the public IP address in case of IPv6. Now the subnetting is very much easy, as I said earlier. It's a /128 in hexadecimal 0 to F. You see this one 2DB8, this one. Now in most of the cases you will find out it is /64. So /64 is this one, has a network ID and host ID. So 128 if it went by 2 is 64, right? So 64 has a, so till here, right? Till here is your um no, not till here is your network ID, and till here is your host ID portion. Okay, so /64 is the host address. Now I'll give you one example, maybe that will be you will be able to understand more what is this IPv6 subnetting works. Now let me clear all or let me go down. Okay, so let me write down one IP address here. Okay, now someone has given me this subnet. Okay, 2001. So by looking at this 2001, I know what kind of IP address, guys, this is, right? So if you go here 2000 double colon 3, right, it's not starting with FC00, so it's not a private, it's a public IP. Okay, actually in IPv6 there are so many address that if you assign public IP to your organization, it will never enter, right? So but see, it's always the best practice to assign a public and private IP address, right? So someone has given this one, right? So now I need to divide this into /64. Now why? Because as I said, right, network ID and host ID, right, /64. So what I'll do, I will say 2001 0, or let me copy, copy paste again this IP. Okay, now what I'll do, I will I'll do the subnetting. Okay, now this double colon I will say 001, right, /64. This become my first network, and if I add a 1 here, 128, right? So meaning this is my network host ID. But if I do this like 64, it is my first network. Similarly, if I copy paste here, if I do, it will become my second network. 3. Now what you can do is, see how many octet you have taken, 1 2 3 4, right? So now 4 more octet left. So what you can see, 0, you can remove this 000 colon 000 colon 000 colon 000 1 is your first, and /128, it will become your first IP. 2 3 4 5 6, all this will become your ID. Now how you can mm, you know mani um, manage this IP, you can give, okay, this octet belongs to my database, right, database team. This octet belongs to database which are where they are in India. This octet belongs to the team who is in India, who is in Bangalore, right? And these are their IP addresses. So like that you can assign the IP addresses here. Okay, now this is IPv6 subnet masking. So I'll give you one example which will be, you will able to understand more. So if I copy this, right, so till here is your my network. Now I will say this is for my database, so I will say 10 is my database, 11 is for India code, 100 is for Bangalore, and these are their IP addresses, right? Now if the now this for database team, 1 to 4 the team who's in maybe in Australia, one who are in maybe in the Sydney 120, and this their IP address. So now by looking at the IP address, I can say, okay, see this block, or I'll write down here. This block will tell me about database, then country, then city, then IP address. See, database.country.city.ip address. Now I know 11 belongs to, I'll maintain a separate sheet. I will say 11 belongs to India, 12 belongs to Australia, 13 belongs to, let's say, North America, right? So if I see any IP address 00100013, I will immediately able to catch, okay, this is for North America. So this is very easy to manage. Okay, now in the last I want to show you one thing which is very interesting, is like, okay, so everyone knows that the IP addresses are shown in this, right, in this format. Okay, 192.168.3.4, 1.1.1.4, or IPv6 are shown in this format 20018 db. But if I ping this, okay, let me show you. Okay, so if I ping this, do you think it will ping or it will give me the error? It will ping, guys. See, I am not pinging 1.1.1.1. I'm pinging some number, decimal number, right? So this decimal number belongs to 1.1.1. So sometimes the policy on the firewall which blocks 1.1.1.1 does not check the internal how the ping works, right? So this how can be the ping works. Okay, so just tell me, guys, how did you know about this, how this ping works? And let me write down somewhere here so that um I'll ask you guys, like, this ping will work or not. How I calculate this number for an IP address. Just tell me if you know, guys, just ping me in the comments so that I know but if you don't know, just ping again, and I'll tell you how you convert this decimal, this IPv4 into this number, decimal number. Okay. Okay, thank you, guys.